Okay, I don't know if you guys are excited about this lesson, but I really am. I loved teaching you polynomial division last year, and I'm excited to review it with you today. Remember long division from elementary school? If you take a long division problem, like 2,963 divided by 47, you have to figure out how many times 47 goes into 29. Well, it doesn't. So you move over one digit and you ask yourself, how many times do you think 47 goes into 296? And I'm just going to estimate 50 would go into 300 6 times. So I think 47 should go into 296 6 times. So then we take 6 and we multiply it times 47. 6 times 7 would be 42. I'll carry the 4. 6 times 4 would be 24, plus 4 would be 28. And then we subtract that product from the 296, which is not really 296, it's 2,960. But it's okay because our digits are lined up. So we subtract and I get 14, which is really 140. I'm going to bring down, though, the next digit, which is a 3, and I'm going to repeat the process. I'm going to ask myself, how many times do I think 47 goes into 143? And it goes in, I believe, 3 times. So 3 times 7 would be 21. I'll carry the 2. 3 times 4 would be 12, plus 2 would be 14. And I subtract again the product, and I get 2. Now there's no more digits to bring down, and if I don't want to have a decimal portion of this answer, this quotient, then I just use 2 as my remainder, and it's technically 2/47. So the answer, the quotient, is 63 and 2/47. We use that exact same process when we divide a polynomial by another polynomial. So, for example, here we go. Let's take 6x to the third minus 19x squared plus 16x minus 4, and let's divide it by x minus 2. Now I know what some of you are thinking. You're remembering synthetic division. You're saying, you could do synthetic division with this one, and you're right. I could, and I will, but I'm going to show you long division of this problem. Okay, so I ask myself, how many times does the binomial x minus 2 go into this binomial? I'll just take the first two terms there and call it a binomial. Well, I don't even have to really worry about all of it. I can just say, how many times does x go into 6x cubed? And it would go into it 6x squared times. So I'd have to multiply x by 6x squared to get 6x cubed. So now I'm going to use that and multiply that by x minus 2. That would be 6x cubed minus 12x squared. I multiplied the 6x squared times both terms. Now I'm going to subtract this entire thing from the two terms that I started with. 6x cubed should cancel out with 6x cubed. I made it happen that way because I'm trying to reduce this. Negative 19x squared minus negative 12 is actually plus 12x squared. So that would be negative 7x squared. Sorry, my pen stopped. Let me pause here. Let me make sure I did that right. Negative 19 minus negative 12 is actually plus 12. So that's going to be negative 7x squared. Okay, now I bring down the next term instead of the next digit, and I begin the process again. I say, okay, what would I have to multiply x by to get negative 7x squared? And it would be negative 7x. So negative 7x times x is negative 7x squared. I'm doing this. And then negative 7x times negative 2 is positive 14x. And then I subtract the whole thing. Don't forget to subtract all the terms. These two should cancel out, and I get 16x minus 14x, which is 2x. And then I bring down the next term, and I do it one last time. X goes into 2x positive 2 times. That gives me 2x minus 4, which, when I subtract, gives me a remainder of 0. So this one divides evenly into that polynomial, which means that x minus 2 is actually a factor of the original polynomial we started with, which would have been useful to know for factoring, right? If we were doing a factoring lesson. So the answer, or the quotient, is right here with no remainder. Okay, now synthetic division. I can do that same problem with synthetic division. So I'm going to go over here. I have enough room right here that I can do the same problem using synthetic division. If you guys remember synthetic division, you basically eliminate all the x's, the subtractions, and the multiplications and deal only with the coefficients of each step of this problem. So you start off, let me get a highlighter going here. Let's go this color. You start off by writing down the numbers that are the coefficients of the polynomial that you're trying to divide into. And so I'm going to write down 6, negative 19. Do I have black ink? Yes. 6, negative 19, 16, and negative 4. You have to make sure that every power of x is represented, because if there's any missing powers of x, you need to put a 0 in as a placeholder for that missing term. But this one has x to the third, then x squared, then x, and then the constant term, so we're fine. In the box, we put the opposite of the number that is the constant term in the divisor, the number that's being divided into the dividend. So we put not negative 2, but we put positive 2 there. By doing that, we actually take care of the subtraction because we've already multiplied it by a negative, so we don't have to subtract. All right, then the process went like this. First number comes down to below the line. Then you multiply the number in the box times the number below the line, and you put it in the next column. So this becomes 12. And then you add the numbers in the column, and you get negative 7. And then you multiply the number in the box times the number below the line, and you put it in the next column. And then you add, and you get 2. And then you multiply, and you put it here, and then there. So you add, multiply, so forth. So these numbers, all the numbers that you see in my little synthetic division algorithm here are actually in the long division over there. You could find them if you started looking for them. 12, for example, that's right here. Negative 14, well, that's here. You'll see that they're their opposites. Positive 4, well, here's the negative 4. So it basically eliminates all the unnecessary parts of the division. And so then your answer is that bottom line of the synthetic division. This is the remainder, if there is one. This is the constant term. And then these are the coefficients of the powers of x. So we still get 6x squared minus 7x plus 2 for our answer. Same quotient that we got up above here. Okay, synthetic division only works if your divisor is x to the first power with no coefficient other than 1, and then a constant term after it. So we'll do one more synthetic division, and then we'll do a polynomial division that can't be done with synthetic division. So let's do this one. Here's one. X to the fourth minus 10x squared minus 2x plus 4, and we want to divide it by x minus 3. So again, the key is that what we're trying to divide into the polynomial is 1x to the first, and then whatever constant term, it doesn't matter. Okay, so synthetic division box, we put the opposite of that number into the box. We put the coefficients of the polynomial we're dividing into, and if there's any missing powers of x, we put a 0. So you may have noticed that there's no x to the third for this one. So I put a 0 to hold the place of the missing x to the third term. That way everything lines up when we do the synthetic division. First number comes straight down. 3 times 1 is 3. Add the 0 and the 3. 3 times 3 is 9. Add the negative 10 and the 9. I'm multiplying the number in the box times the number below the line and putting it in the next column. And then I'm adding the numbers in the column. And then I'm getting this. And I'm getting negative 11. Okay, we got a remainder for this one, but that's okay. Here's the coefficients to our answer. Now you're always going to have an answer that's one less as far as degree goes than the polynomial you started with. So this is going to be x to the third plus 3x squared minus 1x minus 5 with a remainder of 11. And remember, the remainder is a fraction over what you were dividing by. And we were dividing by x minus 3. Final answer, it's a beauty. X to the third plus 3x squared minus 1x minus 5 plus negative 11 over x minus 3. Kind of an ugly remainder. Okay, now, what if you can't do synthetic division? Well, then you have to do long division, and I know it's not fun at all. I'll give you one that's quite challenging. Here we go. Let's divide x squared plus 2x minus 3 into the polynomial 2x to the fourth plus 4x to the third minus 5x squared plus 3x minus 2. Lovely, right? Okay, so first of all, no powers of x are missing. I made sure of that when I picked the problem. So I don't have to put any zeros in. I don't have to put zeros into the divisor or the dividend. We're good to go. But I do have 3 terms, so I'm going to divide into the first 3 terms here. But I really only have to focus on the first one. What do I have to multiply x squared by to get 2x to the fourth? That's really all I'm going to worry about for right now. Okay, so what do I have to multiply x squared by to get 2x to the fourth? I have to multiply it by, well, 2x squared. So I'm going to put 2x squared here. Notice I always line up the terms in the quotient, in the divisor, and in the subtraction. So 2x squared, I'm going to multiply it times all 3 of these terms. That's going to give me 2x to the fourth plus 4x cubed minus 3x squared. And then I'm going to change color for emphasis here. I am subtracting this whole thing. I put it in bright pink so that you don't forget that you're subtracting term by term. 2x to the fourth minus 2x to the fourth. Ooh, 4x to the third minus 4x to the third. I'm getting 0. I'm getting 0. 5x squared minus negative 3. That would actually be plus 3. So I'm going to get negative 2x squared. And I'm going to bring down the next term with 3x. Okay, this is interesting because I don't think I'm going to have an x term in my quotient. I didn't think about that. All right, so x squared, what do I have to multiply it by to get negative 2x squared? All I need is a negative 2, I think. I think I did that right. I don't remember this answer. That's why it's freaking me out. Oh, the minus 2 should not go there. Maybe that's why. Hold on. Eraser. Maybe it should go here. Move it down there. Let's try that. We're going to get negative 2x squared plus 4x plus 6. And then we're going to subtract all of that. And we're going to get 0 here, minus 1x here, negative 2 minus, and minus 8 there. Okay, so I can't divide any more into this, so this is my remainder. And so my answer is going to be 2x squared minus 2 plus negative x minus 8 over x squared plus 2x minus 3. Okay, I'm going to check my work for that because I don't remember that answer. It doesn't look familiar to me, and I reviewed this before. So anyway, that's long division and synthetic division. The worksheet will be attached to your classwork for this week. So good luck practicing your division. Bye.